Today's lesson, lesson 6 in the series, looks at solving inequalities in X and Y. Last lesson was solving inequalities in just X, and we showed our solution on a number line. When you solve inequalities in X and Y, you have to show your solution on a number plane. As with all the other lessons in the tutorial, we start off with what does it mean to? What does it mean to solve y is less than x? And as with all the other tutorials, we're doing the same thing. We're finding the truth. We are finding all the x and y's that make the inequality work. In this inequality, we're looking for all the values of x and y that make the left-hand side less than the right-hand side. It really doesn't matter what the left-hand side is, what the right-hand side is. That's what that says. So let's go ahead and show the solution on the graph. As with solving inequalities in X, the first thing we're going to do is we're going to show the equation. We're going to show y equals x plus 2, and then we're going to decide which side of that line, instead of which side of that number, we're going to find which side of that line does the truth lie. So I'm going to call this not my critical point, I'm going to call it the dividing line, because this literally will break this graph into the true part and the non-true part. So when we do our graph, the solution is going to be above the line or below the line. And what we're going to do, we are going to do exactly as we did with solving inequalities in X. We're going to pick a point on one side of the line, and if our inequality is true, that's where the truth is. And if the inequality doesn't work out, well, we know the truth isn't there and it has to be on the other side. So if we're going to go ahead and graph y equals x plus 2, again, it has a y-intercept of 2 and a slope of 1. So I'm just going to do some points, and again, I just want to do the points for now, and I'd like you just to do these dots. And again, instead of up 1, right 1, I'm going up 2, right 2. So just because I'm going to do something with this in a minute. So there would be the dividing line, and all we have to do is decide, is that a solid line or not? And in this case, the answer is not. We, just like with inequalities in X, we have to decide if it's an open dot or a closed dot. Open dot was the less than, closed dot was the less than or equal to. Well, on our solving in X and Y, a less than is a dashed line, and a less than equal to, anytime you have the and equal to, is a solid line. So again, I'm just going to put some dashes, and the dashes represent not including. So again, I'll make a little note over here, dashed line. That's when you have less than or greater than. And a solid dividing line, meaning including, is when you have less than or equal to, or greater than or equal to. So all we have to do is decide which part of the line the truth lies, above it or below it. Now, the best way to check this is just like I showed you how to check a solution with inequalities in X. Pick a point in the region and plug it in and see if we get the truth, yes or no. So I've given you an example of 1, 3. It doesn't matter which point you choose, just like when you solve an inequality in X, it doesn't matter which number you choose. So this one right here, 1, 3, is right there. And you might have an answer right now that, well, right now I know, given that I plotted it, it can't be included. This is not true because it's actually on the dashed line. So let's just go ahead and see if it's true. And again, the answer is no. And the reason is, well, one of the reasons is when we sub in 1 and 3 into the equation, sub in 1 and 3 into the inequality, we get 3 is less than 1 plus 3. So all we did is we subbed a y for 3 and an x for 1. And again, what that says is 3 is less than 3. And again, that's not true. And this is one of the reasons we have to understand why we have a dashed line and why we have a solid line. So that point is literally on the dashed line, on the dividing line, and given that it is just less than, we can include it. So really, as long as we understand dash means less than, greater than, solid means less than, equal to, greater than, equal to, then we really don't have to worry about the dividing line, and we can check our solution by picking another point. Now here's the point I always suggest you choose. It just makes everything so easy. If possible, choose 0, 0. And 0, 0 is right there, so it's obviously not on the dividing line. And we're just going to check and see if that's true. So we're going to substitute in 0 for y and 0 for x, and we are just going to ask ourselves, is that true, yes or no? And in this case, it's absolutely true. And what we now know is that given that, 1 point works below the line, actually any point. And if you don't believe me, pick any point below that dashed line. Doesn't matter what number pair you pick, it will always work out to be true. So here's how we demonstrate the solution region. We shade it in a little. Don't go crazy. Just a little shading, a little rubbing, and that will be good. So again, when we're asked to find the solution to a system of inequalities, we are still in search of the truth. And graphically, the truth is where, well, the shaded region is. So that's why we have to shade in. We have to demonstrate somehow what the truth is, and algebraically, the truth makes the inequality work. So a lot of this is related to what I tried to demonstrate last, or remind you last lesson. So let's just look at a quick couple of examples, and we're always going to check our answer. So again, our dividing line is, we're going to worry about the equality, negative 1 over 2x plus 6. And again, in this one, I have a y-intercept of 6 and a slope of down 1 over 2, down 1 over 2, down 1 over 2. So I'm just going to plot a few of these right now. And what you would do is obviously use your ruler. But again, given that the inequality is less than or equal to, what that means is this is going to be a solid line. And all I want to know now is, is the truth above that solid line, or is the truth below the solid line? So again, all we're going to do is pick a point and check the inequality for truth. And if you look at the simplest point, it's far enough away from the line that you don't get confused, and we go ahead and we plot it. So I'm going to plot that 0, 0, and I want to know, is 0 less than or equal to negative 1/2 times 0 plus 6. So again, the other good reason about picking 0, 0 is you never have to worry about a fraction. So this one right here, really what I'm asking, is 0 less than or equal to 6? And that's true. So what that tells me is this side of the line is where the truth lies. And we just have to shade it in. Again, you don't have to color it solid. You just have to be able to demonstrate that that's the answer. So here we come to this example again. I've given you 2x minus 3y and 6 a few times. And again, the key idea with this is you can graph this line any way you want. So if we, again, looked at the equality, I would hope you would look at these three numbers and go, wow, it's really easy to find the x and y intercept. So when I plug in a 0, for y, x has to be 3. So there's my x-intercept, 3 comma 0. And when I plug in a 0 for x, I get negative 3y equals 6, y has to equal negative 2, and there is my y-intercept. Now, if you want to put it in y equals mx plus b, go right ahead. Now, the only thing we have to decide now along this line is it dashed or is it solid? And in this one, it has to be dashed. So I'm just going to follow the pattern on the line, also known as the slope, right? And I'm just going to do a few more. So without a ruler, I can draw a pretty good picture. And again, we have a dashed line. So that's all I'm going to do. You would use your ruler. Oops. You would use your ruler. And you would probably do it right the first time, unlike me. Okay, so now, is the truth above the line or below the line? Again, I'm going to do a test point, and if I can manage 0, 0, I'm always going to pick it. So I am going to choose 0, 0, and what I want to know is 2 times 0 minus 3 times 0 greater than 6. Is 0 greater than 6? Obviously, the answer is no. So what that says is the truth is not up there, and the only other place it can be is down here. So just a little bit of mathematical logic, right? And I'm just going to shade that in. So if you've been following along on the lessons, you will notice that a lot of my language is the same, and that's because the math is the same. The picture just changes, goes from 1 dimension to 2 dimensions. The mathematics remains the same. So the other thing we might have to be able to do is, well, we will have to be able to do, is determine the equation of an inequality. So in this one right here, the first thing we want to do is figure out the equation. Then we're going to figure out the inequality. So first of all, our equation would just be as we did in grade 10 or earlier on in this unit. We would figure out our y-intercept, and in this one, the y-intercept is 5. We would pick 2 nice points, and we would figure the slope down to right 1. So our y-intercept is 0, 5. Our slope is negative 2 over 1, or negative 2. So our equation would be y equals negative 2x plus 5. Now, here's what we're going to do similarly to what we just did, going the other way. Now we're going to get rid of the equal sign, and we're simply going to figure out, is that a greater than or a less than? And the way you do that is, well, just like before, you pick a point in the solution region. And again, then we're going to make sure that this works out to be true. So I'm going to pick 0, 0, and I'm going to plug that in. And notice I leave it blank, because all I want to do is fill in the inequality. So 0 blank negative 2 times 0 plus 5, 0 blank 5. All we have to do is put in the right inequality. Is 0 greater than 5 or is 0 less than 5? And hopefully 0 is, 0 is less than 5. So that's my inequality I'm going to plug in, and let me just highlight it a different color. Then the last thing we have to do is decide, is that it? Or do we have to include the equal? And again, because of the solid line, right, this part right here, the underneath, is the solid line. Solid line means include, so we have to have the equal as well. So this looks the same as what we just did. We look at the equation, and then we simply do a test point for the inequality. So the final answer is y is less than or equal to negative 2x plus 5. One more. So again, this one, it is the same line. So again, I'm not going to go through everything we did above. Y is equal to negative 2x plus 5. What we're going to do is we're going to disregard the inequality, disregard the equation right now, and we're going to pick a point in the true region. It doesn't matter what it is, so I'm going to pick this one right here. Again, it doesn't matter. I'm going to pick 4, 0. And what I'm simply going to do is I'm going to substitute that in, and I'm going to simplify that, and then I'm going to put in the proper inequality. Is 0 greater than negative 3, or is 0 less than negative 3? And 0 is greater than negative 3, and that becomes my correct inequality. Now all I have to do is decide, do I include it? Do I put a equal to underneath or not? And given that it's a dashed line, that turns out to be my final answer.